Hey guys, thank you for tuning into CMTEQ channel. On my previous tutorial on stm32 multiple external interrupt with a nuclear board here, I had this external hardware added to the system for my buttons and another one for the LEDs. This board is made with the Azoteq IQS227, which is a single channel capacitive and proximity basically sensor. Now, this particular board was very interesting because it's not a simple mechanical switch like these buttons here. Now, this is a touch, and these touch buttons are powered with the Azoteq IQS227. And when you flip the board around, you can see all the electronics that's going on behind this particular FR4 board here. So the purpose of this tutorial is indeed to try to get to the bottom of this particular PCB. Right, but before we do that, let's quickly briefly look at the data sheet. So as you can see, it is a fully integrated self-capacitive sensor with dual output, that is a touch and proximity. So this is a layout, right? The top view of the IC itself. Okay, so that's the IC we have in this board here. So you've got the T out, that will be your touch out, and your P out is your proximity out. There is a ground. Now the CX is where your input is coming. Now remember, your finger here is your input touch into the device. So that's where your CX pad will be connected. Then you've got your VDD and the regulation. So there it is. And obviously you're going to find a typical schematic for a typical application. So that's the one I have implemented in this DIY PCB. And I've got my CX, which are basically my inputs here. Then the 4 buttons here that you can see, these are where my CX are connected on each one of the IC. Now, this small board here is like an evaluation kit made by Azoteq Semiconductor, where you can basically just break these like a bread and a piece of biscuit and implement these onto your circuit. Right, so let's move on to the next part of this tutorial, which is the PCB layout. So that basically means once you've done your schematic, you move on to the PCB layout, which I've already completed here. As you can see, everything is arranged here exactly the way it is being represented here on this FR4 board. If you are working on a prototype application and you would like to implement some of these touch buttons onto your system, please let me know on the comment section below. I will gladly provide you with the Gerbers file for this particular board, and you will be more than welcome to implement it on your system. Program that is running on this board here. Now we've got our mechanical button as well that is still operating, and I've got my multiple external buttons that can toggle all the LEDs. So these are all touch buttons as we've just discussed now, and this is operating very smoothly as you can see. So you can integrate these on your applications and have it working without any mechanical failures attached to the mechanical button that can wear. So the bottom line here is, if you have an application where you need a single touch button and you want to do away with mechanical button that suffer wears and what have you, you can turn into the Azoteq single channel capacitive and proximity sensor IC that will provide you the touching, right, the touch magic without any problem.